Hello, my name is Mark, and it's July 3rd, 2016, as I create this video so that I can prove and convince all of you that I have invented the voltage synthesizer. I didn't know what else to call it, so I called it the voltage synthesizer. And I want to prove to you that it's not impossible to invent the voltage synthesizers because I have done it, but I haven't gone above 240 volts yet because I need to purchase another isolation transformer to do this, to go to 360 volts or 480 volts. So I will show this in a later video in the future. Now, on December 15th, 2015, I had my first kind of little eureka aha moment. And I built my first working prototype, and what I did was I synthesized 30 volts alternating current AC from 15 volts AC, and I used a 10-to-1 step-down transformer that plugs into a duplex receptacle, and what it does, it converts, or should I say transduces, 120 volts AC down to 12 volts AC, but it was measuring 15 volts AC for some reason on my meters, so I just synthesized that to 30 volts AC. And what I did, I powered up two 12-volt dashboard lights from a vehicle of the 70s, little tiny bulbs. I'll show you these in the future, probably on diagram 3. And they're DC, meant for DC, but you can pass AC through them too, and they'll light up. And what I did, I powered two of them for the cost of one, the electricity needed for one. Or what you can say is I saved 50% of the electricity by powering both these light bulbs up with just the current needed for one. And what I do this by the voltage synthesizer uses a series parallel circuit, and I'll explain that to you in a bit here. Or actually in diagram 3, in the next video, I'll really explain it there. Now, December 31st of 2015 is when I submitted my application to the World Intellectual Property Office in Geneva, Switzerland, and I had a little bit of trouble downloading that or uploading it, whatever. And so it was amazing that I got it done on New Year's Eve. So this is my belated gift to the world, and I hope to have more gifts coming in the future. But a lot of this stuff takes time and a little research and experimenting and stuff, so, and it takes money too, of course. So I have to raise some funds to do all this stuff that I'm endeavoring. And I want everyone to accept this gift, embrace it, and use it, because it's going to change technology, specifically power supply technology, because every electrical device uses a power supply, and this applies to DC current also, but I'll talk more about DC. Right now I'm talking about AC. My patent application is about alternating current. DC is a little different because you have to add a few more things to it. And so this is going to change technology so much if the engineers and scientists of this world accept this and embrace it and begin to use it. It's going to change technology so much that I predict it'll cause an electrical revolution. I don't mean to boast, but that's my prediction. That's my my hope for the future. Now, how does voltage synthesizer work? Well, first, you have to realize that everything in your home, like this lamp here, okay, and your ceiling fixtures, and everything you plug into your duplex receptacles, everything is connected in parallel. Nothing is connected in series as far as I'm concerned. So everything's 120 volts is connected in parallel. except your dryer, which works on a 240 volt system, and maybe your stove and a few other things. But that's just a little bit different. They use different. I'm not an electrical genius like an electrician. I don't know everything, but enough about that for now. But I want to show you this duplex receptacle right here in the wall. Right down there, see? Now I got two cords plugged into there, a black one and a white one. And there's 120 volts going down the black cord and 120 volts going down the white cord. And I use these for charging. The black one charges this laptop computer that I'm using right now. It's an HP Stream that I bought for $269, which is a really good deal. And the white cord, I use that to charge my iPad, first generation iPad I bought in 2011, which is still working. It's amazing. And I'm using iOS 5 for that, so I'm pretty happy with that. Now, this duplex receptacle, there's 120 volts going down the black cord and 120 volts going down the white cord. Now, why couldn't you somehow connect these cords together and make 240 volts? Okay, I thought about that, and I thought about it, and I did a few things, and I finally came up with a solution, and I made it work. Now, what you have to do is connect these in series. Now think of two 1.5 volt batteries in a flashlight. When you connect those in series, they become 3 volts, but the current stays the same as if coming from one battery, but the two batteries are sharing the current 50%. So you have 3 volts in series. So what you have to do with these two extension cords that I'm talking about, you have to connect those in series. But you can't do it because that duplex receptacle is connected to a common source, which is your power generating plant, the generator alternator that's, burning the coal or the oil or the gas or whatever they burn to create the electricity, the steam to create the electricity, that moves the turbines or however it's done. So it's like, think of it as one big alternating current battery. Not actually a battery, but think of it as like a battery, but it's actually a generator or an alternator. So it's one source, so you can't do it. No one's thought of a way to do it before because you can't connect two of them together because they'll short out. And I'll talk to you about that in diagram 1. So I figured out how to do it. You have to isolate these two cords from one another. So let's just say a circuit has the ability to think. Pretend that it can think. You have to make the circuit think that these two cords that I'm talking about are connected to different sources of electricity. Then you can add them in series. So I'll show you this in diagram 1 and 2. Now, enough on that. I'll show you the link now to my invention. There it is there. Oh, I think I showed you the wrong one. Omit that one. This is the one here. Now that top link at the top, if you want to read more about my invention, you have to copy that down and enter it in your browser to get to it. Now also at the bottom there it says patentscope.wepo.int. You can just go to that and then you can right here you can search for this number WO, or you can just type voltage synthesizer basic building block diagrams and you should be able to find it. If you can't find it, then you're going to have to copy all this down here, type it in. I hope you can see it here clearly. Now, once you get to this page, there's little tabs in there, and they say description, diagrams, claim, and a few others. And you got to click on description if you want to read more about it. And then they got 6 diagrams for you to look at. Some of the diagrams are kind of poor quality, so if you have any problem seeing them, try printing them out and maybe enlarging them. Or you can contact me. My address and my email address is in the description and some of the other tabs. And you can find my address and you can contact me if you want. I hope it doesn't get bombarded with too many messages. Now, what else did I want to say about that? Okay, this one here, this top link, if you go to that, it goes to the page which shows my abstract, and it shows diagram 3. And you can click or maybe double click on the image of diagram 3, and it shows it even bigger and clearer, and then you can see that real good diagram 3. But the other ones are kind of poor quality on the video, on your video screen. And so diagram 5 is pretty important. So if you need help, I can always email them to you. Okay, now I want to show you briefly. Here's diagram 1 and diagram 2 and diagram 3. Now, I'll show you this before anything else happens here. Just a danger warning about diagram 1, which is this one here. And I guess I just better read for you here. It says, danger. Do not, I repeat, do not wire up or construct diagram 1. It will not work and will result in short-circuiting damage between a hot and neutral wire, which will trip your breaker switch and or cause an electrical fire. Diagram 1 is for explaining how to connect 2 parallel branches into a series connected circuit. The correct method is shown in diagram 3, so please wait for this in my next video, or go to the link I showed earlier to see this. So there it is again if you just want to read it. So please take warning of this danger, short-circuiting danger, because I don't want to be responsible for anyone that gets hurt. But what you should do when you wire up diagram 3 for the first time, you should use the 10-to-1 step-down transformer like I did. So you're working with small voltages, 12 volt or 15 volts, and it won't cause a lot of harm. But what you can do is go even smaller. If you have a signal generator, or if you have one of those little mini oscilloscopes they have out now, they have a little signal generator in there, which puts out a signal. It's only a volt or something like that, and you can add those together to prove that it works, and you'll never get electrocuted from that or cause an electrical fire with that. So that's what you should do. Don't fool around with higher voltages until you're assured yourself that you can completely build a circuit correctly. Okay, now what I should do is show you diagram 2 first and talk about that. Okay, there it is there. Now, these are 2 alternating current sources. The sine wave represents the alternating current waveform. There's positive there, and the other side is negative. This is one source, and this is another source. Okay, think of them like the 2 batteries in a flashlight. Now, this is a series circuit going all the way around here. Okay, now, but these are 120 volts each. 120 volts there, 120 volts there. Now you connect them like this, from negative to positive. That's connecting them in series. So now you'll have 240 volts over here at the load. But the problem is you got to have these synchronized to the same time base. Synchronized means that they're in phase with one another. If they're out of phase, then there's going to be some destructive interference going on. But when they're in phase perfectly, that's where the crests and the troughs of the waveforms are lined up perfectly on a time scale. Then they add constructively, and it's called constructive interference. So when you do this, you'll have 240 volts at this load here. Now the problem is, if this is say a 100-watt light bulb, you're going to have 240 volts at that. But it'll just draw the current that it needs, which would be 833 milliamps. But the problem is, if you have 240 volts, it's going to make the electrons bounce around more because there's twice the pressure or electromotive force. So electrons are going to bounce around more, bumping off other electrons and other particles in the atoms, in the copper wires or whatever is going through here. And it's going to cause more work. And what's going to happen is you're going to have a brighter light bulb, or you're going to have more heat coming off that light bulb. But because the 100-watt light bulb is designed for 120 volts, the 240 volts might damage it or it might not last as long. So there's a problem with that, but you can think that other ways how to use this, you know. What you could do is put two light bulbs in parallel, and you still have 240 volts, but then the current would divide in half, and you would still work. You still have 100 watts of power working for you. Okay, but that just shows you how to connect them in series, but that's with two sources. What the voltage synthesizer does, it shows you how to do this with just one source. Okay, now we'll go to diagram 1, and I just want you to remember this. Danger, warning, danger. Just pause the videos if you want to read something or look at something. Okay, here's now diagram 1. Okay, there's something wrong with this diagram, so don't even construct it or wire it up. But now, let's talk about this here. Now, here's the one source of alternating current. And let's say it's 120 volts. Okay. Now, what I've done here, it's a series parallel circuit, or actually I should say maybe a parallel series circuit. Because first, what I do, I make two parallel branches. Okay. A and B is one parallel branch, and C and D is another parallel branch. Okay, let's look at A. First of all here, this where this wire crisscrosses the other one here, there's no connection here. This one wire just overlaps the other one, going over top of it. So remember that. Now, okay, this negative part of this source goes to A, and then the positive part here goes to B. That's one parallel branch, and there's 120 volts there. Okay. Now, this negative here goes to C, and this positive goes to D. That's another parallel branch, and it's 120 volts also. Okay. Now, remember diagram 2 where I showed you that series connection. Connecting B to C here will add them in series. Okay. But there's a problem here, because this is the danger part right here between B and C. But just pretend this works. Okay. Now, if you put your voltmeter or oscilloscope over here, one lead there and one lead up here, you're going to measure 240 volts. Because this just shows you how to do it, but how to connect it in series. But the problem here is connecting B to C would cause a direct short circuit between the positive and the negative. See, B is connected to the positive, and C is connected to the negative. So you can't do that because like the hot wire and the neutral wire are going to short out, and you're going to trip your breaker like I talked about, or cause an electrical fire if your breaker doesn't switch off. So, but you would have 240 volts over here again to use that for something. Now, okay, I guess that's all I need to talk about there. But remember, this doesn't work, so don't wire it up or you'll be in trouble. So let's go to, I guess I'm done with that. I think what I'll do is stop the video and make sure this gets uploaded to YouTube, and then I'll talk about diagram 3. But I'll just give you another brief look at diagram 3 here. And I'll do diagram 3. Because there's a lot more to talk about in diagram 3. And then I'm going to continue showing you my prototype, my actual prototype, where I light up two 60-watt light bulbs for the cost of one. So I guess I'll end it now, and stay tuned for part 2 of Voltage Synthesizer Basics, which I should do tonight, and hopefully I'll get it uploaded. So thank you very much for watching, and see you later.